guys. So today what we're going to do is we're going to talk a little bit about the statistical inquiry cycle. You've heard that word inquiry before. If you're going to be inquire about something, that means you're what? Asking about it, right? And you want clear, honest answers, don't you? Right? So if you want to ask if it's going to rain, you want to know if it's really going to rain, not get out and decide that it's raining after you do that. So then we're also going to talk about some things called measures of central tendency. You know these, you just probably do not remember that phrase. We're talking mean, median, and mode. There we go. Yeah. Yeah, those are coming.
That's what that means.
Well, that's what we're doing today, so we're right on time. All right. Okay, so we're going to talk about the inquiry cycle, because the whole point of this section is to learn how to design and interpret a statistical inquiry. That's what our chance of data, that's our main focus here. Okay, so let's look at the cycle. So, no, you do not need to write all these down. You need to write down the names of them, though. Yeah. The cycle. The internet is being really goofy today, so that's why it's so slow. It's PPDAC, also known as PPDAC. PPDAC, for some reason, I have no idea. Okay? Now, so these are the steps of the statistical inquiry cycle, which Mittens is showing in the diagram below. I guess Mittens got the key to the city. Now he's going to teach y'all math. All right. So, yes, you can just write the big words. First, problem. Okay? You need to understand and define the problem you're asking, you're trying to investigate. Right? So you have to be clear about it. Then, the plan comes next. In the plan, you're going to describe what to measure and how you're going to design your study, and then you're going to collect and record your data. So your plan is everything you're going to do to get the data that you need. Then the actual data. You will collect the data. Data management, in other words, how is the data collated? What are you going to do with it? How are you going to organize it? And then finally cleaning it if you need to, right? If you get some weird data that you know that throws off everything. So all you need to do is data. Don't have to worry about the rest of them. You will answer some questions about them. Okay? So data. Then after the data is analysis. And when you're doing the analysis, you're going to sort the data, and typically sorting the data means graphing it, right? And looking at some key factors, some key numbers. You're going to construct tables, plots, and graphs, and you're going to look at it for any patterns or trends that you see in your analysis. And finally, you're going to draw a conclusion. In your conclusion, you're going to make an interpretation of what's happened and draw conclusions. You're also going to check about new ideas. Does answering one question lead to more questions? Usually does. And then you must communicate what happened. So in your conclusion, your communication will be a wrap-up of everything from the problem all the way down. The whole circle. Okay? All right. Looks good? So, how do you remember it? PPDAC. There you go. All right. You're going to see that from now on, I promise you. Anybody planning on taking stats in year 12 and year 13? You're going to really be seeing this a lot. Okay. All right. So here we go. Here are the things. Now, there's some things that you need to know about it that are really important to think about at each stage. When you're stating the problem, you have to make sure that the problem or question is clear. Studying the health of everyone on the planet, not a good question, right? Okay. Studying a specific health problem for a specific population might be a better problem, right? You need to have a plan. Your plan should include everything that can happen, as well as everything that could go wrong. And how are you going to fix it? You need to then collect your data and make sure that your data is unbiased, meaning that, right, if I'm going to ask about the effectiveness of Minecraft as a teaching tool, I probably don't go to a class where everybody's learning from Minecraft, right? And I'm not going to ask Eliza. She's not paying attention to me. Okay. Sorry. All right. Analysis. Does your analysis highlight patterns and relationships and summary statistics such as measure of center and spread? Okay. So many times, depending on the data that you're working with, you're going to be given specific types of analysis that you need to look at, and then you're also going to be asked, what about other things? Do you see anything else that you could add? And then conclusions, drawing conclusions from the data with reference to all the assumptions, limitations, and future improvements that you might make, okay? As well as any questions that it might bring up about, this makes me want to see this, right? So it may create you a new question, pose a new question. Wait. Okay? All right. Remember, this is all in your Education Perfect, so you can get it to it easily too. Okay? Right? So all you really need are the big words. Okay? You don't have to write down everything.
I'm not writing anything.
Okay. All right. Can I go to the next slide now? Oh, yes. Okay. All right. And again, it's on your Education Perfect, so it's there. Okay, guys. Now, when it comes time to display your data, some graphs are better at displaying data than others, and you need to know something about each type of graph so you'll know which one to choose. So, you don't need to write about that part, but you do need to write this part. So, write down pie chart, okay? And pie charts are best used to compare groups. Okay, so you're comparing groups. So their example there, pet ownership in Poland. It's easy to see which pet is the most popular in Poland. Clearly, cats. Yeah. All right. Which ones are almost the same? There are three that are almost the same. Which three? Rabbits, fish, and dogs. Right. Okay. All right. So it's easy to compare groups with pie charts. Bar graphs, one of the most common types of graphs you're going to see, are good at comparing quantities. Right? Because remember that the height of the bar tells you how many of something you have. And so it's really easy to look at a glance. In this case, you just look at the glance at how whales travel to work. Well, you don't need to write it all down. If I was going to write this, I would write bar graph compares quantities. Okay? Don't get carried away. You're not rewriting the book. Okay? So, it's easy to see the one that occurs most is the tallest one. Duh, right? So, most whales travel to work on a hovercraft, according to this data. Okay? All right? Then, the next one we have is something called a line graph. Now, we're going to work with all of these. So this is not the first and only time you're going to see these. Okay? Now, line graphs are great for showing change over time. Line graphs show change over time. Because if you have that line, it's either going up or it's going what? Down, or it can be flat, right? So over time, you can tell, did the price of my stock go up? Did the price of my stock go down? Did it stay the same? Okay? Right? So line graphs are good at showing flatness in time. Okay? All right? The next one is one you're definitely going to see. It's something called a scatter plot. Okay? You bet you did. A scatter plot is a good way of showing a relationship. So scatter plots are used to show relationships. Okay? So notice that this particular scatter plot, most of the dots kind of line up together. Yeah? So do you think they show a really strong relationship? If they line up in a line like that, yes. And it's going up. So it's showing a positive relationship too. Okay? Now, and you also have these weirdos out there.
Outliers.
They could be outliers, but but you can't just say that because they're out there. There's really a mathematical formula that they have to fit, but probably, yeah.
Could you not say, could you say that they outliers and explain why it's going to
You could say that most of the data seems to be positively correlated, but there are a few points that are not.
Would you want to explain this one goes through this, and did it at this time during the day, which means this way?
You bet. Okay? And since we're not really worried because this is about how many books camels read. So, all right. Guys. Okay. The next one is one you will definitely be using a lot, and it's something called a box and whisker plot. We're going to be drawing these. You've seen them before. And they're good at showing the shape, center, and spread of data. We can see, is most of the data clustered in the middle? Does the data go far off to the right or far off to the left? Right? What is the minimum and maximum piece of data? Right? And how far apart are they? So all of that information is information you can get from a box and whisker plot. So shape, center, and spread of the data. Okay?
No, not you. My writing. I was talking.
Okay. Yeah. But again, remember, this is just the introduction. We're going to go through and do sections on each one of these. So this is just the introduction. So don't panic if you're not. I'm not teaching you these. I'm just kind of getting you to see them. Yes, the age of alien civilizations. Yes. Yeah. It's pretty funny. Epsilon boots. Cygnus X3. Don't be writing those down. They're pointless. Okay? All right. So, here's a little homework we're going to go through. And then, I know you love to do this, so I'm going to call on you.
Oh, yay.
Makes it even more fun. So we like the kinds of descriptions that talk about what's happening in the middle because it gives us one number to use to represent a bunch of stuff, right? So it tends. But we have problems with that because what happens to the stuff at the far end and the other stuff at the other far end, it gets kind of left out or ignored in some cases. So you've got to be careful. So but we're going to talk about some measures of center or measures of central tendency. And the most common ones we're going to use are called mean, median, and mode. So what I want you to make sure to write down right now is the mean. This one is often called the average. So when somebody says average, these are all averages. But the one we think of most is the mean, and mostly because of grades, although y'all don't do that. Yes. And to find the mean, you need to write this down. It's simply the total sum of all the values. So add up all the numbers. Sum means add, right? Okay? And then you're going to divide it by how many numbers there are.
There's a song.
Okay? There's a song for this?
Yeah, so you know every one.
Do you know the song?
I'm not going to sing it. No, I'm not going to sing it.
Okay. Come on. By the end of the class, she'll sing it.
Okay.
All right. The next one we can look at is something called the median. Now, you've seen median before. You guys don't drive, so you don't think about it. But you know that strip of grass that's been in the middle of the road? That's the median.
Oh, in the middle.
So it's and where is it? It's in the middle. So that is the middle value. But you've got to be super careful about this. The numbers have to be in order from smallest to largest. So you cannot find the median if the numbers are not in numerical order. Okay? So you don't want to do that. Because there's some other information you can get. So you want numbers to be in order. Besides that, it's harder to put them in number order backwards. And then finally, all right, guys, now think about, and then we're going to look at each one of these and how to get them, so don't worry about it. And then finally, we have something called the mode. And the mode simply means the one that occurs most common. So the most common value. Okay?
If there's two that come in the most, you just have
You can have more, and we'll talk. Yeah, we'll look at a slide about that too. Okay? So, if I say average, what do you normally think of? Mean. The one that happens the most is the mode most, right? And then the one in the middle is called the median. Okay, good job. Right. Okay. I shouldn't have fed him that much
I
sugar.
wrote the song down in my book. It's like literally 2 sentences, but it's really useful.
Okay, so here's an example. Gary, the marine biologist, weighs humpbacked whales. The weights in tons are given below. Find the mean. What is the formula for finding the mean?
Total sum of values.
Add them all up and then divide by what? The number you have. So they added them all up and got 326. There were 10 numbers, which gives you 32.6 as the mean. Okay? Good. I'll try. All right. Now, I do want you to notice this, though. Watch, look. So the mean weight of these 10 whales is 32.6 tons. In statistical data, the answer is never 32.6.
It's gonna have the thing on it.
You have to state what you're measuring, and which measurement it is, what you're measuring, and the number.
So how much you want?
Just like they did. The mean weight of the 10 whales.
You mean their answer was wrong?
No. Their answer is perfect. Right. Okay? So be aware of that. Okay? Okay. Now there is a drawback to using the mean. Guys, come on. You can have a set of data where there's one number that's way different than the others. And that one piece of data can throw the mean way off. So look, for example, at this. They're talking about the survey of cats, the ages of cats in years. The ages are 5, 1, 2, 42, 4, and 3. One of these things is not like the other. Right? A 42-year-old cat. So when you take the mean of this data, you get a mean value of 9.5. But if you look at this data, does 9.5, that means the average cat lives 10 years. Does that make any sense? No. So that data point throws the data way off. But if you take it out, you get a mean of 3. Does 3 represent pretty much what's happening there? Yeah.
Can you remove that?
Okay. So, yes. Okay, so be careful. All right, when you're doing the frequency. Now that's easy when there's an odd number of numbers, but if you have an even number, then what you have to do is take the 2 in the middle and average them.
So if it's 4 and 5, it'd be 4 and 5.
There you go. So say, for example, we had 4 and 5 in the middle. So we had 4 and 5 in the middle. We would just take 4 plus 5 and divide it by what? 2.
Or you could just go 4.5.
Okay. Well, I just picked easy numbers, right? Yeah, because there were 4 and 5. Okay? All right. Now, okay. So they're finding the number in the middle here. We have 1, 2, 3, 4, 5, 6 values. So that means there are 2 in the middle. So we add the 2 in the middle and divide by 2, which gives us 479.5. Absolutely not, but sometimes the numbers are not so close together like that. They've given you really easy examples here. Okay? All right. Then, the mode is the most common number. So looking here, is it easy to see the mode here? Yeah, it's a lot easier if you put them in order. So anytime you're working with these, if you put them in order, it's a lot easier. But you can just count them, right? There's only 1, 2. There's a 3. 3 4s, right? So you could put them in order as you go.
I think it's below. Oh, that taco.
Okay? Shut up. All right, so you can have more than one mode. I'm sorry, I was thinking of something we were talking about earlier. So you can have more than one mode. You can have 2 modes, in which case it's called bimodal, like bicycle, right? Now, if you have 3 or more, then the mode is worthless. So it really doesn't tell you anything. So if you have 3 or more modes, we usually don't even say there is a mode, 3 or mode. 3 or more, you usually just say there's no mode.
They're trying.
Right? But you can have trimodal in a set of data, but it just doesn't do you any good, right? We usually only do it when there's one mode, because that tells us something, which number occurs more frequently. But if there's a bunch, and you could have another case where there's no mode, no number could appear more frequently than any other, right? Okay? All right, so here she goes. You're going to have to do some, group the numbers together and find the modes, find the pieces, read values. Okay, so that's all in your homework. All right, there is. So, you need to know the range and how to find it. Range is easy. Range, you just take the biggest number and subtract the smallest number from it. So that's the biggest one minus the smallest one gives you the range. Okay?
So it's like a spread of data.
There you go.
Oh my god.
There you go. Yeah. Good. Now, then they give you this phrase, the upper quartile.
Oh, yes, we did do.
Often abbreviated Q3 because it's also known as the third quartile. That's just the middle number, and a middle number is another word for saying, what is the word for middle number? Median. Right. So that's the median of the upper half. So in other words, let's say you have some numbers, 1, 2, 3, 4, 5, okay? Well, there's the median, right? Oh, I need more numbers to demonstrate this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So, what's the number in the middle? 5. So that's the median, right? Because I'd already written something. Okay? Now, then, for the upper quartile, we're going to look at these 4 numbers and find the median for that. Okay? So that this one has an even number, so it's 7 and 8. What's halfway between 7 and 8? 7.5. So it's usually called Q3 or upper quartile or they call it UQ there too, upper quartile. Has different names. Usually it's called Q3 though. There's also a lower quartile, which is exactly the same thing except you're using not the top set of numbers but the bottom. Now notice I'm not including the median in any of those. We've already used it, it's done, right? Okay, so 2 and 3 gives you 2.5 as quartile 2. I'm sorry, Q1. Sorry, Q2 is the median. Okay.
We memorize it as Q3 and Q1.
Absolutely.
Okay.
Yeah, but you can also say upper because you know it's upper because you did the top numbers. You know it's lower because you did the bottom, and we're going to do lots of exercises.
If you said upper quartile,
Yes.
that would be fine.
Q1, like upper quartile 1.
No, because that's just too much.
Okay.
All right. Okay. Now, and we also have something called the interquartile range. Range, again, means just take the highest value minus the lowest value. So if it's the interquartile range, that's just the difference between the highest quartile, which is 3, and the lowest quartile, which is Q1, right? So those two pieces. So we'll go for the 7.5 and 2.5 from the example we did. Just Q3 minus Q1. That gives you the middle of the data. Yes?
When do you need
Most of the time you see this when you're analyzing box and whisker plots.
Okay.
Yeah. Okay?
They'll like ask you what you
Yes, you have to know those numbers in order to build a box and whisker plot. Okay? Good deal. All right. So here's some data, for example, rainfall data. Okay? First step, they put it in order, because obviously it doesn't rain in order. Okay? Then they found the range by just taking the maximum minus the minimum. So the range here was 3.2. Then they found the interquartile range, so divide the data into upper and lower halves, making sure the median is in the middle. So the upper half is this stuff, the lower half is this stuff, right? So you find the median, pardon me? Yes, you see how they have some space between? So what they've done is they took the median, found the median. That's the point where it breaks it in half, right? So then you use this stuff to get the upper quartile, this stuff to get the lower one. Yes?
So say you have 8 numbers, do you just have to split it in half like 4 and 4 to make your median like
Yeah, because the median is going to fall in between those. Mm-hmm. Yeah. Good. Good, right? And so there you get your quartiles. And then, of course, from there we can then get the IQR, which stands for interquartile range. Thank you so much. So that represents the middle half, the middle 50% of the data.
Was it 2.5?
2.5. You are so good. Excellent. You are. There's another example. Again, just leave them in order. Why did they break it in half here?
because there was an invisible.
Yeah, there were 2 numbers there, so that means there's the median is the average of the 2, right? So, okay.
So if there's 2, you just find out what's in it.
What's in the mean of them? Yep, there you go. Okay. All right. And the last thing is just a display pie graphs. Again, we've talked about these. They're just divided around in half, divided into pieces. They're good for comparing what? Groups. Excellent. You go, Lucia. Good. Bar graphs. We use those. Those are good for carrying what? Quantities. Excellent. Now, histogram, we didn't talk about it, but it looks like a bar graph, right? So, but notice that there's stuck. There's no gaps, right? Because a histogram displays continuous data. So it's continuous, right? It's not discrete. It's continuous. Excellent.
What about this is like bar graphs that have like 2 kind of data on one?
Okay. Yeah. So you can have double. Yeah, where you're making comparisons. Yeah.
One I get really confused.
One we haven't talked about is stem and leaf plots. Right? Stems and then the leaves. Right? Then we also have dot plots. You're going to see lots of dot plots. Each dot just means one of them. So how many 3s do I have here? 4 3s.
Will it always be just one?
Not always. It can be more. It could be more, but they'd have to give you a different scale. Oh, I'm sorry. Stem and leaf is where they just give you a stem. Notice it's 19, 20, 21, blah, blah. And then the leaves go off to tell you. So this would be like 19.27 or something. We'll talk about them more. They're good at comparing numbers and seeing the spread of data. Okay? And then finally, box and whisker we talked about. All right. So